Anyway, so about today's topic, it's only one karma that actually works in our life. Okay, so the idea of this presentation was like appeared, I don't know how to exactly say it, after few knowledge evaluation that I conducted. I am knowledge evaluator at SoftServe, and I could extract to the most painful items for for people to to understand and to pass it. Concurrency, like parallelism concurrency, and so on and so on and so on, and security. So as for security, we have special group for it. So if you have any problem with this, you can request any trainings. But as for this parallel programming, it's kind of problem. So I'm not going to dig really deep into some details of some framework. I'm going to give you some basic understanding of this approach of parallel programming. We'll give you some examples on Async IO and maybe some alternatives like the history, and we'll try to give you better understanding of these approaches. We'll try to clear some myth, and as a final, I will give you some popular frameworks that exist and couple advices how to select framework. Okay, so couple words about me, if I make this thing working. My name is Oleksandr Lazarchuk. I'm from Rivne. I've been working at SoftServe for 10 years, about 10 years. Mostly work on project for from a couple months to a year and a half or something. So my experience is about almost everything, because 10 years it's very hard to keep the pace and do not be bored. So hopefully SoftServe allows me to play with almost everything that I want. So hello, this is a code written by some senior on the client side. It's supposed to be Courutine code. It's supposed to be parallel code, but it is not. So I will give you some hints why a bit later, but this code is completely useless, and it will be blocked. It will be run as a regular code, and all that fancy stuff that you see on the screen could be just omitted and pushed away. We will go through some items, and I will go back to this slide and explain you why this is a piece of not a parallel code. That's what I exactly wanted to say. So the big problem with the concurrency, parallelism, multi-threading, and so on, that there are a lot of information about it, and it's been written in the way that were hard to understand and understand and reproduce. And I had a nightmare that I'm passing some interview and I could not tell what is concurrency and parallelism are. What are. So two funny videos about concurrency and parallelism, real. One. Yeah. So imagine that you have three tasks, and you have a couple of workers that need to handle those tasks. And the worst way of implementing it to make a cool task that does not allow anyone else to touch my tasks. So, but this is a very funny example of multitasking, concurrency, because you have three tasks and you have one worker that work with all of them. And another one, it's more like a parallelism, because as you will see, the concurrency is more like a working like one for many, and as for parallelism, it's more like a many for one. Yeah, so you will see like one task, it could be some heavy task, it could be like CPU bound operation, like calculation or very hard calculation. It could be some regular input output, like database read write and so on. So as you see, it's very good example of parallelism. Okay, get enough of the jokes. Let's let's start some serious stuff. Problems. Why do we ever need any like fancy technology that nobody understands? The first problem that appears in any like philosophy and then later in programming world, the problem of five thinkers. So imagine that we have five. It should not be fork. It should be like you know that noodle stick. It's more obvious. So imagine that you have five thinkers, five bowl of noodle, and five sticks. One single thinker could go through the flow. Thinker start thinking. Thinker take the like left stick, then thinker take right stick, then thinker start eating. Then vice versa, the thinker put one stick, put another one, and start thinking. The main problem here, if you do not synchronize them, we will appear in the situation where every single thinker, will take left or right stick, and everyone will be blocked. Because there are no any flows that allows you to take the one stick, try to take another one, and then put the first stick or something. Yeah. Oh, sorry. So this is a problem, and in parallel programming, this problem called deadlock, where everyone blocked by each other. And another problem that my right arrow does not work. Ah, sorry. Yeah, another problem, it's chess. It's very popular, like kind of sport or something, when one person, like very, I forgot the name, like chess master or something, want to play with several people at the same time. And like, imagine the chess master has a line of 10 chess players, and if chess master will play with entire entire game with one by one person, it will take like a lot of time, because the period of thinking, it's idle time for either chess master or regular chess player. And this is a problem. And the solution for this problem is this session of parallel game. I don't know how to say it in English, basically. So the chess master go to the first player, make a move, start the time, and go to another one. And the same. And there are like couple versions, like regular concurrency or asynchronous concurrency. Like just chess master go one by one. And it will take much less time, because for chess master there will not be any idle time, except the case when chess master go back to the player and player still thinking, so chess master go to another one. And the third option that I don't really want to put here because of advertisement stuff, but I will speak it out loud, McDonald's. I really doubt that At least any person here from 30 with something participant never been there in McDonald's. So imagine like situation in McDonald's, then you order something, and the flow is like you stay in queue, then you stay in line, then you make an order, and then you wait. And till you waiting, another person in the queue is served. And this is another one great example of like this concurrency, because your idle time doesn't mean that everyone else should wait. And also as a like nice bonus, if you order several things, you also don't need to wait like till everything entire order will be ready. You could take it like partially. First of all, you order like burger, cola, some, I don't know, like pie, and then cola is ready, you take it, pie is ready, you take it, burger is ready, you take it. It's another one great example of concurrency, and it was a solution for the main problem. People stay in line like forever, because if line is too long, they don't need to wait. Okay, any questions here? Nothing. So what is concurrency? So before we even start thinking about multi-programming, multi-parallel programming, and multi-threading programming, any kind of parallel programming, we need to like go back to the concurrency. So concurrency is something that controls your flow. Yeah. So concurrency is the way you split a lot of big tasks into small tasks and try to handle them separately. So you do not block the flow with the very big task. You like granulate or split this task to many small ones, and you go with this flow, small, 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 instead of big, medium, small, and so on. I will show you the profit of this approach. And it's not parallel programming. Concurrency is not like real parallel programming. In programming world, there is a term like cooperative multitasking. So it's more like you split, you cooperate, and you split the task to a lot of multitasks. And it's important because concurrency, like in like 10 years ago, 20 years ago, okay, 20 years ago, we used to have only one core. And it was kind of impossible to have real multi-programming, multi-processing language, because core is like, we have single core, and it was not possible to like parallel something, but it could be parallel because of this concurrency, because of this cooperative multitasking. So each flow, it's like regular thing, each flow has some time for execution, or it could be partially executed because of this splitting. And like, as you see, we start first task, start second one, continue first, start and end third one, and first and second. And now imagine if the task number 3 is something really small. And in real world, as you see, it will take a lot of time to receive the result for a small task. It's kind of not really useful for us, because like the same case, you have 4 requests from different users, and one user wants to get just the one word, like one simple config, and another one wants to get the big file and something. So this case describes the situation when all users, like user 2, 3, and 4, wait till the user 1 download the film, the movie. And if you work with cooperative multitasking, you will see the picture like this. Task number 1, it's the biggest one, and it will be completed on the 50 seconds, 50 minutes, 50 seconds. It's more obvious situation, 50 seconds. And then user, like second user needs to wait more time, the third one, and the last one will probably close the page and like, I'm not going to use this site anymore. But in this case, if you split up the task, the request by part, and HTML allows you to do this. In HTML, you can describe the like blocks. You download the data if you don't know it. So you could like split the big request to small one and return data by chunks using chunks. And as you see, the user number 4 will take the result very soon. And the user number 3 is the same. The problem might be for user number 2 and number 1, but as I told, the user will see progress anyway. User will see that download first 10%, like 25%, 50%, and so on and so on. So this is concurrency. And concurrency is not like a real parallel program. Concurrency is like concurrency for the resource. Yeah. So the several tasks, several handlers stays in the concurrent state and wait to grab the resource to be executed on that resource. And this is concurrency. This is main principle that stays like beyond entire parallel programming process. Parallelism. So this is like the approach when you, like real parallelism, when you take the concurrency and apply it to many or single core. So concurrency is approach, but the like multi-threading or other parallelism approaches is more like a realization of the concurrency. And it could be used for one core, for many cores, doesn't matter. It should be like, to be real parallel, it should be concurrent. If it's not concurrent in the single task, it should be concurrent on the many cores. Yes, so you could split the one task to like to 2 tasks, and each task will be concurrent for single core. And as soon core will be ready, it will take the core. So try to like review the situation as a like from different perspective. If you go very deep, you will see concurrent on the task level. If you go a bit like if you have a bit wider view, you will see that concurrent will be on the level of the core, and so on and so on. So you could like zoom it as much as you want. And like as I told, it could be run on the different cores. And then the biggest problem of Python developers, for some reason, they don't really know what the GIL is. It's hacking me out sometimes, because like, come on, you're working with Python like for many years and you don't really want to know what the GIL is from the perspective of development and the parallel programming. So GIL is a global interpreter lock that everybody knows, but nobody knows what the lock is. So in the thread primitive, there are, thread primitive lock is an object that holds mutex, and mutex is the flag that allows or deny any access to resource. And GIL is just a log that block user, prevent like core to be executed at the same time inside the process. So, which is mean that if you want to calculate Fibonacci numbers, calculate any primitives, any prime numbers, anything, it would be a problem, because GIL will not allow you, because the first thread running, I secure the lock, and nobody else could I secure the lock. And right after the thread is end, the join, the GIL release the lock, and another thread could I secure that lock again. And the biggest problem here, the Python code is not thread safe, like C Python code. is not thread safe, and this is a problem. And another problem here that GIL does not allow you to run thread on many cores. So each thread will be run on the single main thread, on the one core, and so on, unless you do any spawn process or something like this. So yeah, everything run in the single core. But like I often hear hearing the phrase like Python doesn't have real threads. It like, how to say, it's not correct information. I will say like this. So Python uses the same thread, and the main purpose of thread is to be on the operational system, hold the context, and so on and so on. So Python has real threads, and Python has everything that you need for like thread, like parallel execution, unless you want to have some CPU bound operation, but we will talk about this later. So the main feature with GIL that if operational system, if GIL sees that you use input-output operation, it releases the lock. It releases the lock completely. And for example, if you read the database from the Python and you do it in correct way, the engine for access to database lives on the operational system level. And Python will see that you do not has any request to do not try to access the process shared memory, yeah, and it will release the lock. And this thread will wait. This thread will still live in the operational system and will wait till input or output operation will be ended. And at the same time, another thread in the Python will start execution. Will like execute the lock and start execution. And this is the main principle that stands beside any thread, multi-threading programming, and asynchronous programming in the Python. Also, I'm hearing, even reading some articles about the concurrency versus parallelism, but it should not be versus. Like the main problem here that for some reason, like people that try to create multi-thread or like multi-thread programming, like thread pools or something else, forgetting that inside it's concurrency. Because even if you have like couple cores, each thread will be concurrent in concurrent state. It will be like this chase problem. Yeah, it will be chasing for resources. So we will use thread for execution and concurrency for splitting. So concurrency is for splitting resources to be able to chase the resource, and thread will hold the execution, will be responsible for execution for all that kind of shit. And remember, the GIL itself, it's just a lock for the memory. It's just a simple lock that's global. And the same if you have any application and you have this multi-threading application, but you put the lock. And each time that you assess the application, even if the small function, you will execute the main lock, and anybody else will not be able to do this and will wait. It really looks like in database there is a transaction isolation level serializable or serialized. Every single transaction will wait till the another one ends. So it's kind of chain. Yeah, that's all. And multiprocessing, it's almost the same, but the zoom is very, very like on the long distance, and you see the context. So all the time you make multiprocessing, you make a copy of the process and shared memory and execute it on the separate core. It's Multiprocess means that you have, it could be also be executed on the single core, but it will be managed by operational system. Anyway, so you make a copy of the process. So you will have two processes, and then each one will be executed separately. It could be on the separate core, it could be on the same core using concurrency and so on and so on. But this is multiprocessing. And the main problem here as well is APC. This is an inter-process communication problem that you need to synchronize two processes. Imagine that I need to buy two different things that placed in different stores on the different edges of the city. And I need to do this at the same time. I need to go there in market number 1, in market number 2. And I have 1,000 hryvnias or euros or anything else, any currency. And I need to do it in parallel. I have two persons that will help me with this, like two processes. And I have only 1,000 hryvnia. How does this multiprocessing work? I have 1,000 hryvnia and I give everyone for 1,000 hryvnia. You know? And then everyone go to each market, buy something and give me a change. And imagine that first item, first device cost like 500 and second one 400. How many money will I have after they return back to me? 100. Even if I gave them 1,000, this spent 500 and this spent like 400. These have 500, this 600. After they came back to me and give me everything else, like all change and each device, I will have 100 because I need to synchronize the expenses and the initial value that I had. And because of this problem, we have GIL in Python, because Python really struggle with this synchronizing. And like there is a alternative for this, like spawn processes. Like, as you know, I will use everything else. Like that will not copy. It's very nice feature. You should read about this. And in Python 3.8, they fix some internal, if you spawn something or fork any process. The Python 3.8 has the internal, some integrated kind of APC that will synchronize it automatically. So it will be more like I have 1,000 hryvnia, I need to buy something for 900 hryvnias in different places. I will not give anyone like the 1,000. I will give them like paycheck or something, and then they give the paycheck to the market, and market will ask me to give the money. It's more like very strange system of spawning process and sharing the memory between spawn processes. But anyway, read about this. And imagine situation that I need to union all those approaches. So I have like 5 big tasks, like really big tasks. I split each task to small one. I have 5 threads that will be responsible for each task, and I have like 3 cores. So we will join everything, and like there is a mistake here, is task for execution, concurrency for splitting. So I will have a thread, and the thread start execution on the core number 1, second on the core number 2, third one on the core number 3. The fourth one will be waiting till any core will be available and put there, and this core will have 2 threads that will be concurrent for the resources, and the different tasks will be executed kind of at the same time, and the velocity will be extremely high. So don't need to choose. You all the time you could use it together. And even for Async IO, you will have the run in thread pool executor or process pool executor. So you will run everything, like you will have your async code run in the thread or run in the process, and then you can fork if you don't need to synchronize the different processes. And it will be like very, very high performance application. So what is async basically? So, so imagine that you have concurrency and you need to run these asynchronous, I don't know how to spell it in correct way. It's always a problem for me, such bad, like very hard words in English. So imagine that you need to execute something and you don't need to control the flow. So in the multi-threading, like parallel multi-threading programming, the task execution itself is on the operational system level. Operational system should have basically a scheduler. It's some like very intelligent person, intelligent application that know who's gonna be next. So basically it's a lane manager. And the problem is that this lane manager lives on the operational system, but we know that the thread itself, it's operational system object, and it's heavy. And the biggest problem here that if you have a lot of heavy objects, the scheduler will spend a lot of time just to switch in context, just to switch in between threads, and you will lose a lot of time because I need to find this object, I need to take the context, I need to init it with this context, and it's very heavy operation. If you have 5 threads, that's fine. It will not take a lot of time. But if you have like 200 or even 1,000 threads, for you it would be like really, really big pain. Not exactly for you, but for operational system. And the most time the OS will spend for switching context between threads, but not the execution exact thread. And to resolve this problem, imagine that we want to have own scheduler. Someone that will take the responsibility of managing the tasks in the concurrent programming language. Okay, so we are not going to speak about Async IO right now because it's kind of new technology. We used to have and we used to use in a couple projects the alternatives that really works like really asynchronous. And for Python, it was like very good example and good performance improvement because some libraries allows to do not work with real threads, but convert them to green threads. It's more like you will also need to read about green threads if you never heard about it, because it's a very nice feature that allows you to work kind of with threads, but it's more like Courutine. It's more like a sub-process, very small one, and all management will be on the level of Python. Yeah, as you see, like we have eventlet or G-event. I use G-event with Pyramid on like my previous project, and it was very helpful because Pyramid works with one thread, and you know that if you work with Pyramid, you get it from the get single thread, and then you get all information about that lives in this thread, and then you can run something. So I don't really remember the names of those. It's more like some hub for G-event or eventlet, but like anyway, in real world we call it loops. Loops, it's kind of some infinite cycle that all the time go through each state and do something. Another example is monkey patching. So The problem here, all the time you work with async, you try to do some operation that will release the log, like input-output operation. And as you see, sleep is input-output operation because you ask process to sleep, like you ask someone to sleep. So basically you run some timer, and timer, this is operational system stuff. And then here request, you get some URL from the request module. And basically GIL, if you ask GIL, will release the log here. But the biggest problem in most cases that developers uses bad functions. And like bad functions means the functions themselves are good, but they are not in the place they should be. So for example, the request library and get method is blocking method. And if you have a async programming and if you try to open the get, you will be blocked because nobody release, like you don't say the loop, the internal scheduler, do something, release the log, wait. And then let's go back to the example I shown you here. The connection, the report, like reporting DB connection, anything, this connection used with operator, that basically, if you don't know, the async IO allows you to work with as a sync in a sync way, async with, and their magic function a entry, a exit, or something like this. Yeah, with the a on the beginning. And this code is blocking the get result itself. So first of all, do you see any yield here? No. So it's like Python version 3.4. It's very old code. In like it was the time that we used generally Courutine. Like I will explain what it is if you don't know. And here any code should use yield, and I will explain you why. So this code is mostly useless because it will be blocking. And this coroutine, this loop will take no effect because everything will be blocked by this get result request. And this is a problem that you also need to understand and avoid. And even if the get result is the, like you will see yield, or in real world it would be await. If get result is blocking function, if inside this method you will not provide anything that will notify loop that this is something blocking, you will be blocking. So let's go back to the async section, and like again, blocking and unblocking function, I will try to explain you in examples. So you try to create asynchronous code, yeah, and you try to like call something like sleep or so on and so on. And in most cases, you need to use all like async version of those functions. If this function will have like simple return, which is fine for threads because operational system and the scheduler will understand that this is a call to someone else, and will notify GIL to release the log, and everything will be fine. But in async in Python, it will not happen because the scheduler will not understand that scheduler need to do something. So basically, scheduler need to notify GIL, release the log, so I could switch. Give me the control back so I could switch the task. And it's also a problem because I very often see that people use the blocking function inside the async code. To avoid this, all async libraries have own versions of blocking functions, like almost. For example, sleep, request, and so on, we have own versions. Another way is monkey patching. In some versions, in some libraries, that allows you to patch, like you do in tests. You patch object to return the data you want, like with side effects and so on. Monkey patch do basically the same. Like if you run monkey patching, they try to find all blocking function and change it with some additional code that will notify GIL or loop or something else. And this one is important. Heavy task the same. GIL is still here, and remember that in Python, async code is run under main thread. And anyway, in Python, you run blocking code. And inside the blocking code, you start the loop, you start this scheduler, and inside the loop, you run async code. And it will be this very, very fancy switching inside the loop, inside the thread, because like you have one thread and you have everything inside the thread. And if you run one task, IO, GIL is like GIL releases, but the same thread, but with this another task will secure the lock again. So remember this. And if you have very long task, very heavy task, like long cycle or anything else, and you really want to make this like concurrency. So remember about concurrency principle in async. So async is not about the giving the control, giving someone back. Async is also concurrency. So split your task on the several tasks. Imagine that you need to make 10 requests and then do something with those requests. So each request will be ran as expected, like one request, then another task, and so on. But if you have then some result processing, and you will have like for E in 10,000 and go through the results. Remember, try to make chunks, like make chunk like 100. And after each 100, each chunk make sleep. Make sleep, and it will allow Python, it will allow loop to switch the task. Remember this, if you do not use input-output operation, you will block everyone else. But you could use the sleep functions or other functions to like make the real concurrency flow. WSGI is blocking. It's like really blocking. And there is an async version of WSGI. So again, read about this. It's very useful. And if you're a Django developer, it will be useful for you. And since, like speaking of the devil, so Django is a sect. And I've been in this sect for some time. And if you work with Django, you know that Django, the main principle of Django, backward compatibility. We still have a client that 10 years run our application with Django 1.0. We need to support them. We do not phone back our like users. It's like US Army. They are our folks. And this is the main problem. And this is the problem why channel died, that and other. But there is async in Django. There is. You need to like dance a bit with tambourine, but it's possible. If you work with Django, you will understand me. If you do not or did not, just like forget whatever I'm saying. So you will have like if you work with Django and you want to make it async, you need to split a lot of stuff. You need to have base handler async anyway. And it will communicate with ISGI interface. Then you need to have WSGI and ISGI at the same time. And you need to split your views to like async and sync. You need to split like Django ORM that don't really can into async, but it will really try. It might be a problem. That's why you need to split views. because you need to at least request like make something async. Then if you use test views, it could be a problem for you as well, because like test view could not, like test view is blocking, and everything that you will use like base handler is async already. So you need to use some special sync to async and async to sync method, because you need to change handlers and change, like run the event loop somewhere. And again, this is a small information about Django developers. If you want to hear more details about this, you can ping me some after the presentation, and I will try to explain you the reasons. So about event loop. So this is a kind of basic example of event loop. Like you have an event loop, you create a task, you want to print something, you want to compute something, you go back. As you see, you yield from sleep, because sleep also yield, it's also coroutine, and so on. So you basically, on this second, if you use blocking task, it will be like this. If you use unblocking task, like async task, you will run them like this. And in between, you may have another task. So you just split by, you print compute, you yield for sleep, then you return sum. The same, imagine that this is a big task and you need to process something, that could be like parallel. Yeah, split by chunks and sleep after each chunk. It's very good advice for you, because it might be a problem if you make this application. It will block everything, and it's not good, as you might expect it. And again, basic example of event loop, it's like infinite cycle. Like, give me something to execute it, exit. Again, what do I have? And go again and again and again. It has some queue, task queue, and it works with these. And the loop itself should be quick, and we will speak about the different options, different loops, and so on a bit later. Yeah. About async.io itself, I will try to do like this. Yeah. So this is Python 3.6, Python 3.6, and earlier 3.5. You need to get loop. You can run it forever. You can assign loop to application. You can do whatever you want. You can run forever. I will give you some example. You can run until complete. You can run task. Also, you can set your own priorities. I give this example because problem number one, nobody closes the loop. This is something I'm very frustrated about. It's more like do not close the file. It might be a problem for operational system because it eats resources. And it's bad because it could be memory leak in your application. The next one that nobody uses, almost nobody, but in my entire career, nobody, I never seen that, anyone except me use the call later and call soon. Call later, if you want to call something, but a bit later, just wait a bit. And call soon means that you set the priority for this task a bit higher. And loop will try to call this function as soon as possible, as soon as that will be the free slot inside. Also, the priority could be managed by another way, but in different way, and it mostly depends on the loop itself. So the event loop I'm showing you now, it's an event loop that goes from the box, out of the box with async.io. But we will speak about another loops. And they could have another priority. So basically, remember, the event loop is a scheduler. It's someone that knows what to run and where to run. And I gave you some example about context and so on. So what is Courutine? Yeah, so never try to search information in Wikipedia. It's a setup. It's a trap. So even like even me with my years of engineering and working with this parallel programming, I could be confused with the exam, like a description on from the Wikipedia. It's so smart for me, and like I have no idea who has written this and for whom. So all the time, if you work with Python and you want to get information about Python, use only .python.org. So what is Courutine? The main problem that nobody understands what Courutine is, and like in operational system there is a subroutine, like routine, you know, like the task you need to do and so on and so on, and just like regular task. And subroutine and something that like will try to manage this routine that you need to do a lot of stuff. And operational system use the subroutine as the example. And coroutine, it's something that's used inside the interpreter. And not only Python uses coroutine, like another languages also could use coroutine example, coroutine implementation. And basically what the coroutine is, it's a function that has entry point, exit point, and what? The function that could save the context. And the funniest thing in Python that we already have generators. And generator is the function that know its own context and all the time save it, because if you dig in Python, you will know the term like stack frame. It's a frame of like a frame in memory where we hold everything, and all the time we go into function and yield from the function. We save the point, we exit this function, and when we come back, when we call this function again, we will back into this point. And this is something we get for free in Python, and that was the main start point for async, like async IO in Python, because loop will use the built-in functionality of Python as like generator as a coroutine. Only one difference between the regular generator and the coroutine. The coroutine know how to notify user, notify loop that I'm done, or you can do something else, or like do some another stuff. Starting from Python 3.5, when async IO is built in and we don't use coroutine, we use async await, and it's more like, it's not like pure coroutine. So to be like, to have a deal with your consciousness, we call it like awaitable function, not like a real coroutine. It's more like an awaitable function. Then future. So also you need to remember that all that stuff and inside the C code, it was partially taken from Node.js, because it has very nice realization. I don't remember the name of the lib that was taken for the realization of this some feature of async. So there are in different like sources, they have different names for the task that in the process of concurrency. And there are in JavaScript, there are deferrers, promises, other tasks called futures. Here we use only task. In Python, some libraries use futures. I think Tornado uses futures. So what a future is, this is something that you start. If you put something in the queue, you just wait. If you start, do something, you are future. And the task in Python, in async IO, it's more like extended future. That future means that you start something, you're going to finish something. If you like put the parallel with the queue, with the lane, a line in McDonald's, if you stay in the queue, you just a regular, you wait, you something, I have no idea about your existence, but right after you make an order and wait for the order to be received, your future, your task that I can manage to, I know your index, I know how to call you, I know where you are, because I see you through the camera, you have a number, you can ask by yourself with your number, is it ready, or I could notify you by your number, or I could send someone to notify you, and so on. So I know about you, the system, the loop, know about the existence of you, and know how to call you, and so on. And also one other thing that very important, if you work with Tornado, you know, and you work with JavaScript, you know that all async code, it's something like callback functions. Here the same. Imagine that I run myself and put myself at the callback. So I run myself one time, I will yield, I will wait till input-output operation is done, and after it's done, I will call myself. So I will put myself into loop again. But the context is the same, but the iterator will be shifted in generator next to the another item. So it's more like a calling callbacks for myself. It's a bit harder, but for you to understand in easy way, after my code is complete, call myself again. And it will be done till stop iteration rises. Right after stop iteration rise, right after generator rises stop iteration, which is mean nobody to execute, loop will free you and will close the task. Bit of code. Yeah, so it's very simple code, very simple one. Like if you never work with this, it's an example. I have a callbacks. I have it's awaitable. I have first, I have second. Each first and second has sleeps. First has sleep, second does not. So anyway, and I will try them run. So as you see, the result be cut it for some reason. But anyway, waiting for first, in first, waiting for second, in second. Yeah. So as you see, the code will be run in some sequence, which is very important. How to close this thing? Yeah. Another example did good, did better. So the same. We can work with tasks. I can create each awaitable function as a task and process it, and could run forever. Also, I can change the result, the entire process with this code, which be more sexy but less readable. So the reason why I put it here is if you write code, it could be less sexy, but should be readable and maintainable. Also, it's kind of the same code, but written in kind of different way. So you await all tasks, you run until complete, and so on. It's more like you can gather the result in some way. You can do the same with the creating task because you have a handlers and so on, but it would not be readable and maintainable. So remember about this during writing the code. And closed loop. I'm watching. Yeah, queues. This is the main idea of all async code. It's queue. It's queue that should be managed by someone. There are two different queues, like async and sync. Yeah, the difference between async and sync queue is when you get it's very the main one. Yeah, if you get from queue, sync queue, and queue is empty, rise an error. If you put into queue and queue is full, rise an error. In async, if you get from the queue is empty, you start timer and wait till somebody puts something in the queue. Right after queue will not be empty, I will notify myself to get from this queue again, and I will get this item. So get and post and like the size and some other functions are awaitable functions, awaitable methods. And this is like main difference. They coroutines, they patient because they wait, and it's not thread safe. So it's like we need to remember this because you know you can put and imagine that you get the size and you put something. Yeah, so it could be a situation that you get the size, you see that I have one free slot and I will put there. But somebody without getting the size already put something. So that's not thread safe code, so remember about this. Everything that awaitable could not be thread safe if you work in the different executors. So remember this. There is a like good library Janus for queues. It's very slow library, but it's a good because it could work in both ways. So imagine that you need to work with async code and threads, and you need to manage it by like simple library, like one single library for both. So you could use Janus because if you work threads, Janus will work in blocking way. If you work with async.io, Janus will work with as a awaitable way. A bit more about like queues in the example of code. So producer consumer model, it's required on knowledge evaluation for intermediate plus. So be aware of this. Imagine that we have two awaitable functions, like one produce, second one consume, and you need to somehow like switch the data between them. So you will have a queue. You create the queue. Async.io has own queue. If you work with threads, you need to use queue from threads. If you use async.io queue in threads, you will get in the situation that someone puts into queue, like someone get the size and another one puts something in the queue. So queue will not be blocked by some mutex or anyone else. So use the queue and then you produce and consume. And then you produce some items and start consuming the items. And as you see, I put something, I put here, I'm start consuming, then I put again, then I get again, and so on and so on. So it will be infinite cycle. I could make this queue size less than like 10, or like in some case more items get, and then it will be, how to say it, infinite loop. I could have like queue size less than 10 and put 5 elements, and it all while true queue size or something, and then like the consume and produce will be ran forever. And for some reason, a lot of people forget about. Oh, I have a message in chat. Yeah, thank you. Future came not from Twisted, it's like came from some book. I don't remember the name of the book. It was like one person tried to, I'm answering the item in the chat. So there was a book, like very old one before the Twisted. And they like use the term like future for this concurrency programming. And when I spoke about Node.js, I mean that the realization of coroutines inside the C code use the library that came from the Node.js library because it's fast and quick. It's something that in the nutshell. The future itself, like as I said, JavaScript has like the promises, defers, and so on. Futures is another concept that like migrated from like other libraries. But anyway, it all came from the old books that try to like explain the math beyond the one more message. Yeah, thank you. Thank you, Ivan. You Google it, right? You could speak out loud.
Yeah, yeah. Hey everyone. Actually, yeah, I've Googled when it actually has been provided, right?
Yeah.
But yeah, I heard that you mentioned Node.js as the first place where actually futures were introduced. So I didn't agree with that. That's why I actually shared my thoughts and my opinion.
Yeah. Thank you. It's very nice. Maybe I like it means that I explain in the different port that like not everyone understand or agree with me. So again, the coroutines, the examples of the loops and so on from the C perspective of Python was taking the idea and some libraries from Node.js. I don't remember the names and what exactly, but I'm pretty sure that I've seen some libraries that migrated from Node.js, like C libraries. And as for future, as the same as defers, the promises, the task, and other primitives for concurrency programming came from the old ancient books, like were older than me and like the most of you, and maybe older than some of your parents. Anyway, it's very old items. So go back to this, like we have producer consumer model, producer consumer or produce consume model, and we have a queue, and for some reason like developer forgetting about using the queue and using the queue as a separate item for communication between items to something to like make the executor and just to provide data to executor through the functions. Another example, producer consumer model with a bit more items. And as you see, I'm adding, like I add 6, then start the consume, then add finally. You see that I put the sleep here. Then I consume everything. If I put the right await with the sleeps, right await with other stuff, I will get the like picture like adding 1, 2, 3, consume 3, adding like 4, 5, 6, and so on and so on. So look at the code and like and try to put the parallel with your async code. Try to use sleeps if you have a lot of while or for or any kind of cycles. Try to put correct await. Try to use use the async versions of any function, because imagine that I put here not async sleep but like time sleep, it will be blocked, and nobody will do anything until the sleep is complete. So remember about the blocking vs unblocking. The same, like good example, but there is like 3 dots. It would be something on the top side. But anyway, you will see numbers, number 1, 3, 4, 3, 4, 1. So I will have like different consumers, like consume 1, 2, 3. And you see, like I consume different items, and the order is like different. So remember, use awaits in the right places. Use sleep if you do not take any request but process data. And even here, when you use queue, which is awaitable, also use sleeps. So here, like put, it will like release, go back, then you need to process some data or calculate some data, sleep. It's important. And the main problem that I think 20% of people on the KIE answers in the correct way. When use what?
Multiprocessing versus threading.
Multiprocessing, CPU-bound operation. CPU-bound means that you calculate something using processor, using memory of the process. When you bound the memory-bound operation in the CPU process, so anything that should be calculated in the CPU use processes. In the Async IO, if you want to calculate something really independent, use process pool executor. You could run the loop in different executors, and there is an option when you can create the pool of processes and use this. And each task will be concurrent for each core. Basically, Python will create different forks for the process, and everything you put there will be executed in different processes. But remember, if you need to synchronize the data, it will be a problem for you. Threads and Async IO, only input-output bound. Only input-output bound operation, like reading socket, reading protocols, reading files. It might be a problem with Pythons. You need to find a better library for open in reading files. What else? Reading database. Very funny situation. You could use threads for synchronized processes, because one of the inter-process communication primitives is pipe, which is unnamed file. It's very funny thing. If you can do this, it would be awesome. And Async the same, because Async is the running in the thread with own executor. Then waiting period. Process controls the tick, the wait, the when to switch context. Operational system in process at the same in threads. But remember, thread is the heavy object, really heavy object. And if you have a lot of them, you will be in trouble. In Async IO, executor on the Python side, the scheduler on the Python side, the primitive that handler is just regular generator with some fancy stuff inside, and it's already know the context. And the switching context is just a call in the function. Operational system need to go to the warehouse with all threads, get the proper one, init it with the context, and init it in scope of the process of Python, versus Async that already there, and you need to just define the call, and that's all. Using many cores, again, Python is not as thread safe, and we have a GIL. So basically, you can use stackless Python without the GIL. And there is a library, I forget about this library that the stackless Python came from. It's GIL-less, and it could use several cores using threads, because anyway, no GIL, no log, no mutex, go ahead. But Python is still not thread safe code, so be aware of using this. And the main problem is scalability, why we have Async in use more than threads. In process scalability low. My laptop has 16 cores. Yeah, so some laptops 8 cores, some 4. Even with the multi-threading, hyper-threading technology, you could have twice more if you have i7 or something. But 32, 16, really, it's too small. It's not worth to try. In threads, I could have hundreds, hundreds. I know, I even see the examples with the up to 1,000 threads were running, but have no idea how they managed to do this, because for me, 100 threads means that all the time I need to just tinker in between the threads. And in Async way, you are not limited, you're limited only by the loop. how many items the loop can handle. And it could be like 10, like hundreds of thousands, decades of thousands, and like many, like a lot, like really a lot. But the problem is you cannot use standard libraries. You cannot use request get. You cannot use like all the like some HTTP libraries that you got used to it. And if you want to migrate your project to async and you use a lot of blocking functions, just do not. Stay blocking, but stay safe. And the second problem that it will be very hard to manage the, like really manage the schedule the priorities. In the threads, you could use some like leverages for operational system scheduler to make it run faster. But in loop way, like if loop does not provide you to any like leverages, you will just wait till it will be completed the way loop sees it. And like GIL, as again, process GIL doesn't like care about. In threads, GIL yes, but again, it will be releases under input-output operation. And for async, GIL is not the case because we already in the one thread. So we will work with the way that thread will be like GIL will release the memory, and the thread will, the same thread will ICQ this lock with the different task. So it's not the case for us. Did like couple frameworks that will be useful for you, like Tornado, Twisted, Sonic. Be careful with Sonic. It's fast, it's quick, but like it had a lot of problem with big requests. So I read the article about the Sonic is created to die fast, and there are a lot of options that allow Sonic to die and suffer, but nobody else from async frameworks, like every else async framework, like accept this and work fine with this, like in this environment. So I will try to dig more into it. IOHTTP is very nice one. I was pretty pragmatic about this framework, but I met the like guys from UA, and they told me that they use IOHTTP and extremely happy with it. And then I like dig in again and find something about IOHTTP, some benchmark, and it appears to be really cool. Because I was very skeptical about this because of no information, no benchmarks, but it started appearing. And that's kind of funny because IOHTTP, I think it's the first async IO based web server. And that's kind of fun. Django, it's fast, it could be async. If you have enough time. Ya pronto, it's like Spanish, I think. It's very nice framework. If you want something like very small, it's microservice for micro framework for microservices. It's like extremely fast, but extremely hard to maintain. So that's like trade-off. And a lot of them, like Watsons, Schmatzons, any other frameworks that you might see, or the like have a framework, put something like some HGI framework there that support HGI, put async await for views, and voila, you have like something async. This is like example of benchmarks. Like it's more like some average request per time, or like something like this. And the less is better, and it's a single request, something like with async, like async stuff. So as you see, Django is good, IOHTTP is good, Flask and Sonic are the same because they basically the same, and Tornado is really bad. But don't believe graphs, because First of all, you have no idea about servers they ran on. This is very good example about comparing Node.js server, Go server, and like Sonic server and Minefield. Mainfield is very nice and really fast web application server that you could use with supporting the like supporting Async. And all like checks that you will see in internet might be like, okay, I'm running Sonic on Sonic, but I'm running like Tornado on something like really fast. And I will get the huge performance increase just because of the server. The second item, loop. This is a good example of comparing. So you see, like I'm trying to imagine that I want to compare HTTP tool. It's something like it's a library written by Magic Stack, the author of UV Loop, to parse HTTP request response and so on. It's more like a web op, if you know what the web op is. Imagine I want to compare like HTTP tools with like UV Loop. You know, like I just comparing UV Loop with something like on the site, and Async.io, which is run on the Async.io loop. And I'm like, do you see the Async.io is better than UV Loop, the IO HTTP. But the problem is that what integrated on different loops. Here I use UV Loop for IO HTTP that was not made for this. But here I use different tools for parsing. But we'll show you the example that Async.io is better than anyone else. It's like about comparison. Remember that you will not see the all information from those graphs. Try to do your own math for your own example and put together different items. Remember, you need to have in web development, you need to have WSGI handler, that basically the person, the library that parses request responses. You need to have like web application server as well to support requests as a method to create requests in a sync way. You need to have event loop, and it should be a very fast one. You need to have very fast queue, and you need to have very fast and async server that you will like connect to traffic or the engines. Yeah, if you use Apache, you have no options. You should use ModWSGI. Yeah, but you could use the like Unicorn. You could use UWSGI or UWSGI. I hate this name, but anyway, and so on. So remember this. And the last item. Also, always try to find the benchmark with different sets of options. So for example, Tarantul is NoSQL database, very cool one. And there is a different pages that used for testing. And you see that used even different Pythons. And Python 3 and 6 in 10, 20% better than Python 3.5 because of the GIL implementation, because of the other cool things, mostly because of the GIL and the ticks, and like different loops, different requests, different libraries, everything. So try to find, try to search the better benchmark with detailed information, but not that benchmark like here, which tells me nothing. I will take Tornado and it will be slow in my case because I use different set of libraries. Okay, that's basically it. Do you have any questions about all that mess that we spoke about today?
Hey, once again, it's again me.
Yeah.
I'm sorry, maybe I again heard it not in the correct way, but you mentioned that channels are dead for Django, channels as a library, I'm sorry. Is it true or?
It's not true because nothing that in Django. But the support of as I've been told by Django from like my previous community, the Django channels supported like I'm not sure about the having new version of Django channels, but the old version is supported like really poorly compared to other libraries that related to Django. And like even in the internet, I'm hearing less and less about Django channels. So it's not like a real death. It's more. It could be like a thing. It will be rise like a phoenix sometime later or not. But now the channels like go into some this like sleeping period or something because not like too how to say it, too less information about this. Very hard to find something new about these new approaches and so on. So it's more like a figure of speech.
Okay. Another one question is about closing the event loop.
Yeah.
So I'm absolutely on the same page with you that you should do like that to be absolutely sure that you close all connections and you quit in your program in the correct way. But I'm just took a look inside the source code of CPython and looks like this close method, what it actually do in Unix Linux-based system. It just pushing the signals to all coroutines and saying you should terminate, and that's all. In that case, we will think more when you will close your process, then your memory will be free as well, right? So about what memory leak you've been talking, I'm interested, and maybe you have some user cases, your cases, where you actually can prove it that there might be some problems if you will not close the loop.
Yeah, so as you told that to clear the memory, you need to close the process. But the problem is your application could be still running. So I think you all got used to working with event loop when you start event loop when your application start and work with event loop when your application closes. And in real life, you could have an event loop inside your application somewhere and you will run and close it like by some, like hitting something. Like I'm working in a really blocking way. I do something like do some calculation, and then I need to temporarily open the event loop to make a 10 requests to different databases, gather the data, and then work, keep working with them. And in this case, if I do not close the loop, and for some reason some coroutines take the memory and did not release it, so like just like for some reason create some like how to say it? I forgot the word. Okay, ask for some memory and did not release this memory. And without closing the loop, nobody will notify any coroutine to like shut up, close it. So it might be a problem. And coroutine could run, and if you do not close it, and it's like in some infinite loop or something like this, it might be a problem.
Yeah, in that way, yeah, it's definitely can be.
Yeah.
So, and the last one is just, it's not a question, but some notes from me. For those who actually think that GIL is bad, you should rethink your thoughts. More than 10, 20 years ago, Guido and Rossum actually tried to replace GIL with some another thread-safe things, and it actually gave nothing. The speed was the same, and still it was ugly. And I will post a link to this article right now in the chat.
Yeah, it would be very helpful. And I just remember about, you mentioned about closing loops, and in Python 3.7, there is an option for lazy. You could make async run, and it handle everything. It will create the loop and close the loop after. There is a run function, very funny one. Like remember, Python 3.7, if you use early version, it will not work. Yeah, thank you for the article. In Python 3.7, you could use async run and put everything there, and it will be handled. So you could use it as well. Any other questions?
Yep.
Yep.
It's not related to the async Python, but to the concurrency.
Mm-hmm.
Imagine you have some threads running, and at some moment you need to stop this thread and continue doing another job, or return response or something like else. Is there any solutions how to stop these threads? Because in the Python documentation, there is no any implementation to stop the threads. They still running in the background. And after a while, we will have hundreds or thousands threads running in the background until they're complete.
Yeah, because
and what to do in this way?
To handle this way, this problem in programming world, we have a pattern that called thread pool.
Yeah.
So only one way to do not allow working with hundreds, thousands of threads, you will have a manager of those threads, and you will manage them inside the pool. And instead of creating new thread to do something, you just work with the existing one and just push task for them.
Yeah, but in this case, we have a thread pool with a number of threads.
Yeah.
For example, 20. And when all these 20 threads are blocked, we will not handle any incoming requests, for example, if it's a web server.
Yeah, that's correct.
The client will be blocked.
Yeah, but this is a problem not of Python, but any language. So if you work with threads, you need to understand that you need to somehow synchronize them, and you should use some primitives. So threads themselves could be communicated with anything else, like semaphore, the lock, the signal, the anything else like this. So for example, you need to lock all resources, you grab the lock, you iSecure the lock. You need to release that, you release this. So you don't need to, you could send some information to thread, but it's not a very good way. You could send some information using some simple signal queue, and each thread will have the access to this queue. You could, to avoid any blocking, you need to iSecure all locks for your flow. In the way of, remember the case of thinkers? Yeah, before start thinking, you wait, you try to lock both sticks and then you can grab it. Before grabbing first one, you need to be sure that second one will be blocked and nobody else will touch it. So you need to do this. It's again, it's more it's not about the Python documentation, it's about approach of parallel programming itself. So remember, we have primitives for threads like semaphore, mutex, critical section, lock, the object that holds the mutex, some airlocks, yeah, and they communicate somehow with different items. And the second one, processes, the same. You need to somehow communicate between processes. The regular version is a pipe when you communicate with the output, because every pipe sends something to input and receives something as an output from the another. Yeah. So when you run the application from the console, you run application and you could put something, and application prints something in your console. The same console is just to run your process, establish the pipe, and get information. Have you seen the message broken pipe in socket or something? It means that the pipe that will take the information from the socket is broken and you could not receive any information anymore. And the same, you could not send anything to the socket. This is inter-process communication. This is something how you communicate between these primitives or processes. So remember about this. It's not about Python documentation, it's about the entire programming, parallel programming dogma. Yeah, dogma. Yeah.
Just a few words. I was researching the same question. I can't remember right now how long ago. So yeah, there is no correct way to terminate the thread outside of the thread. So you always need to think how it should end up in internally inside the function you're actually trying to execute in the thread, right? So there are a lot of primitives like timeouts, signals were mentioned. So, and again, Sasha was right saying that terminated the thread outside is not about the Python. So it's incorrect way of doing this for all programming languages.
The only way to stop this threat that you do not need to wait for is to run all of them inside another process. So in that case, you can kill process and then all threads will die. But in our case, that doesn't work because our server doesn't survive forking, and that's all.
Yeah. So in your case, you need to have some another queue for messaging, or just lock resource, and thread will die by itself. Because if thread cannot execute something, it will like go back to the pool, and then you should have some housekeeper that will clean up idle queues, idle threads. So you need to just reimagine the system. You control the threads, you give the task for threads, and you need to put locks or at least semaphores. Yeah, and also in lock in Python there is a message like notify all.
I know.
Yeah. So and everybody who holds this lock or like semaphore or anything else will be notified. Like notify about ICQ and notify about locking, and like you need to implement the threads in the way to understand this message. It's more like an event. You send an event.
It also works with threading event, but you need your thread to run some loop, for example, while loop. But if you do not have any loops in this thread, it will not work.
Concurrency. Remember, like try to split up. Try to split up to hold the control.
Okay, thanks.
Any other questions?
Yeah, hi there. A small question, possibly a little bit general. You showed us some pieces of code which look supposed to work asynchronously, but actually it doesn't work that way. So the question is, how could we identify such things in our existing source code to be able to fix it or prevent them in future and test like such cases?
Yeah, it's a very good question. Only one answer is code review, and that's all. Because there are not like in most cases, Async.io will not allow you to run some blocking code or like async code from the blocking, and in some cases they might not notify you like at some warning that you run some blocking connection or something. But in most cases, it's kind of impossible. Because the idea of async code is you could still run the async code, because async have no idea what are you want to do with this code. Maybe it's what on purpose you really need to run this one in async mode and in sync mode, and then run something in async mode, because you need to use this result for async queries. So it's almost impossible to do in automatic way. So only code review. Only like spot check all your available functions about width. It should be like async width. Use async from yield quiz. Sorry. Like wait. Yield from, and so on and so on. And every time you get a connection, check if you use the async version of any blocking function, and that's all. It's only manual. You cannot run async from blocking, but it's possible vice versa. Only manual check.
Okay, thanks.
Sorry.
And thanks for presentation.
Yeah. So that's all. If you have any question, feel free to pin me in Teams. I mostly like sit there. I hate Skype for Business. And if you want some piece of code or advice, or you have some problems, or like you have no idea how to like resolve some issue, just feel free to ask me, and I will try to help you. Or at least I will find the person who can help you with the same experience as you, like with the same stress you're trying to go. Yeah. Yeah, so that's all. I think we could stop recording.